Hey everyone. So I'm back here in the circuit simulator. I've made another circuit. I guess it's a mixed series and parallel circuit again. I'll show you the current going through there quickly. Well, it's not going all that quick. It's got to go through this 5 ohm resistor first. Then it goes here, and it's going really looks like small amounts compared to the when you compare the 10 and the 30. More going across the 10 compared to the 30. All right. Um, So let's look at how we deal with something like this. All right, so I have the picture of that circuit right here. What we're going to do is, we got part of this cut off, so this is a 5.0 ohm. All right, so we would say that this 5 ohm resistor is in series with this parallel combination of the 10 and the 30. So we have these two are this is in series with the rest of the circuit. So another way of saying this is all of the current that comes out of this battery is forced to first go through this 5 ohm resistor. Then it goes up to here. Some goes this way, some goes this way. Now, when we get into further analyzing these circuits, we're going to see that 3 times as much current goes through the 10 compared to the 30 because it's 1/3 of the resistance. But that doesn't matter right now. So here's what we're going to do. We need to take these two elements first that are directly in parallel with each other to figure out their equivalent resistance. So what we'll do is we're going to label these. I'm going to call this one R1, R2, and R3. Okay, so I am going to say that 1 over, let's call this one, let's call it R2, 3. So that's 1 over the RT basically there is equal to 1 over R2 plus 1 over R3. So we get 1 over R2, 3. So basically this is 2 and 3 in parallel. So we got 1 over 10, 1 over 30 is first, plus 1 over 10. This makes 1 over R2, 3 is 1 over 30 plus 3 over 30. If you're wondering how I got that, I just times this one by 3 and times this one by 3 to get a common denominator. Okay, so now we got 4 over 30. And just add 1 plus 3. The bottom number stays the same when you're adding fractions with the same denominator. Okay, that's 1 over R2, 3 if you can't see it. Now this is equal to, we can't do equals to. We're going to do R2, 3 is 30 over 4, which would be 15 over 2, which would be 7.5 ohms. Okay, now what we're going to do is we're going to redraw the circuit. So I'm going to replace those two resistors that we had in parallel with a 7.5 ohm. So we got the battery. We got this 5 ohm resistor still. We come up here to where the junction was. And basically from that side to the other side now, we're going to have just a plain old 7.5 ohm resistor. So now you'll notice that that we have a series circuit with a 5 and a 7.5. So now to find the total resistance, we just say RT is equal to 5 plus 7.5, and that will be equal to 12.5 ohms.